Hello and welcome to Patch Math, where today we are going to patch your math knowledge on solving quadratics. I've gone ahead and uploaded a problem bank one of my students shared with me if you'd like extra practice. But for today, we're going to go ahead and focus on number 29 because it involves all the steps that you need for problems like these. In order to factor quadratics with the greatest common factor method. That's the method we're going to be using today, but also solve them and the why behind the how we do these steps, because for some reason when this is taught, that why doesn't get covered well, and it's rooted all the way back in properties of mathematics that you've known since elementary school. So looking here, when we're solving a quadratic, I want you to know we have more than one solving method. Today, I am going to use the factoring to solve quadratics. So we have this property in mathematics called the zero product property. So I've gone ahead and uploaded all the mathematical properties that are commonly used on the whiteboard, and you'll see the zero product property is right here. And it says that if we have two things, all right, being multiplied together, and the product is set equal to 0, notice this only works for the number 0, then one of those factors, one of those things, must have already been 0, or they were both 0. So you'll see that here they have a times b equals 0. Well, that makes sense, because if a were 0, then 0 times b, well, that's 0. If b were 0, then a times 0, well, that's 0. If both a and b were 0, then 0 times 0, well, that's 0. And that's why this works. Now, you may be saying, hey, Kalo, there's no product here. Well, the reason I wanted to show you that property is we are going to manipulate this equation so that way we can use that. That's the goal. So we got to know where we're going to know what to do to this equation. So the zero product property basically has two parts. A product set equal to 0. So that's the goal. I went ahead and just wrote it to the side that we need to make this a product set equal to 0 to use the zero product property. So in this case, I see that I like my leading term to be positive. So I'm going to bring that negative 21x over to the left-hand side. But we can't just do that arbitrarily. We have mathematical laws that say what we do to one side of the equation, or the equal sign, we must do the exact same thing to the other side to retain the original value of the equation. I see that this is negative 21x. The inverse, the additive inverse of negative 21x is plus 21x. And I wanted to say that word, those words, additive inverse here, because I don't know why. You are taught that property in elementary school, and it rarely comes back up again. But it actually comes up a lot, and this is one of the places it comes up, and it's just skimmed over. This is the goal, or this helps us reach our goal. We have a goal of getting 0 on one side. How do we mathematically get 0 on one side without accidentally deleting information that we don't want to delete or violating the laws of mathematics? Additive inverses, and then what you do to one side, you do the exact same thing to the other side of the equation, and you're done. So add 21x to each side. These cancel, but what students are gonna skip, and I see it all the time, is when something cancels with an additive inverse, that sum was 0. That sum is 0. Please make sure you write both the left and right hand parts of your equation. Over here, we want to go ahead and put this in standard form just for neatness. We're going to start with the highest exponent term there. That is 14x squared, and then plus 21x. Now, we have part of our goal done. So we need, which is set equal to 0. Set equal to 0. One part of our two-part goal is done. Now, our second part is a product set equal to 0. How do we make this a product? Well, whenever we are undoing multiplication that's already been done, we factor. We're like, okay, well, we got two terms in this case. How do we undo multiplication in two terms? I want to bring you back to this property list again because these keep coming up. We also learned the distributive property, which is down here in its own little box. All right. And what we're going to be using today is the opposite of that. We have been given something where the distributive property has been done. In other words, a common multiplied part in both of those terms. And our goal is to undo that distributive property, to bring out that common multiplied part. In other words, we are going to find a greatest common factor. We're going to factor that out and go from there. So I look here and I'm like, okay, the 14x squared and the 21x. Let's look at the numbers first, 14 and 21. What common factor do they have, right? So I kind of just start testing them. I use my divisibility rules. They're not both even. 2 doesn't work there. 3 works. I take that back. 3 does not work. I don't know why I said that. 14 is not divisible by 3, Kayla. 4 doesn't work here. 5 doesn't work here. 6 doesn't work here. But ding, 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 we have a winner. 7 does work here. So part of our greatest common factor is 7. Actually, I'm going to write this above the greatest common. This is like a little greatest common factor slot here. Just labeling it. So 7. And then I'm like, okay, let's look at the variables and see what common multiply part. That's all that factoring is that multiply part. We've got an x squared, so 2 multiplied x's there in the first term. And then we have an x, 1 multiplied x. And I'm like, okay, 2 multiplied x's, 1 multiplied x. They both have at least 1 multiplied x. I go ahead and bring that multiplied x up front. Now that we've pulled that greatest common factor out front, what's happening when we factor out, we're undoing the distributive property. We're undoing multiplication. So, undoing multiplication, we do that with division. Now you may be asking me, why, Kayla, can you do that to only one side of the equal sign? Why are we not doing it to the right-hand side? And that is because the 7x is staying on the left-hand side. We're not canceling it out with any inverse or anything like that. It is staying there. That information wasn't added or taken out. It was already there. We're just showing it in a different form. So that's super important here. We're undoing distribution that was already there. It was just done. Well, 14 divided by 7 is 2. And x squared divided by x is x. And 21 divided by 7 is 3. And x divided by x is 1. And 3 times 1 is 3. And so we get 2x plus 3 there in the parentheses. Now we don't want to forget, we're dealing with an equation that has 2 sides. We still have the set equal to 0 over here. Now, the question is, have we met the second part of our goal? Do we have a product? Yes, we do. We have a product that is set equal to 0 now. And now we can use the 0 product property. So if the first part, 7x, it could have been 0. The second part, 2x plus 3, that could have been 0. Or both of those multiplied parts could have been 0. So we want to explore all 3 hypotheticals. Well, we do that by going, hey, what if, all right, what if this 7x, that 1 multiplied part, all of that 1 multiplied part equaled 0? So that's the first hypothetical. And then we ask ourselves, okay, the 0 product property said that could have been 0. We'll solve that, but in a minute, we're going to put a note in there. We're going to pause for a minute on that. Because we want to ask ourselves the hypothetical of what if this other multiplied part that I highlighted in blue there, what if that were 0 as well? Because it could have been 2x plus 3, all of that together. It's super important. We do want to go 2x plus 3. We're considering the whole thing here. That whole multiplied part in parentheses, that could have also been 0. Well, now we've got 2 hypotheticals where we can use our equation solving skills that you have been learning since pre-algebra in order to solve these. The way students come to my lessons when they're first taught these is teachers will teach them to guess and check. I don't know why. You've been solving 1, 2-step and 3-step equations since before Algebra 1. So by the time you get here, that is like one of your foundational math skills. It's actually quicker in most cases, like 2x plus 3 equals 0. To me, it's quicker to do that on paper with equation solving skills than it is in my head. I'm more likely to get my sign correct, and I'm more likely to do fractions correctly on paper. So do yourself a favor. This is not anything new or complicated. You've seen this since pre-algebra. Some of you, even before that, equation solving skills. Well, equation solving skills says we are doing the opposite of the operation of how the number is attached to the variable. Looking at 7x equals 0. I go, hey, I want to solve for x. 7 is attached by multiplication. I'm going to divide it off from each side, because the opposite of multiplication is division. Well, 7 divided by 7 is 1. And again, these properties are everywhere. So the property that we are using here in disguise is this one down here, the multiplicative inverse. We want x to still be there, so we don't want to get 0 in front of that x. It's super important. We don't want to cancel that out. Well, how is x retained? If we're going to get what's attached to it by multiplication away, we divide that off. We get our multiplicative inverse that are where 7 divided by 7 equals 1. Whatever divided by itself is going to equal 1. And then this multiplicated identity property is 1 times x is x. So again, these properties are everywhere. You learned them in elementary school, and then you pretty much just talk about like 2 of them going forward, the distributed property and the commutative property. But these are everywhere. So 7 divided by 7 is 1, x divided, or 7 divided by 7 is 1, 1 times x is x, and 0 divided by 7 is 0. So x in this case equals 0. And that makes sense. Over here, we're going to do the same thing, but notice we got 2x plus 3 equals 0, so we have more than one operation. And this is where students also get confused, and where this was taught weird in pre-algebra by a lot of teachers. They'll just say start away from x and move toward it, which is a good pattern, but it's not guided by instinct. And you learned all the way back in elementary school PEMDAS for your order of operations when simplifying the operations as they are given. That's parentheses, exponent, and multiplication and division are created equally, and then addition and subtraction are created equally. Well, if you are doing the opposite operation, you are going to be using opposite PEMDAS here. And so I want you to know you can undo these operations in a variety of orders. That is true. It's going to look more complicated depending on what you do. If you decide to divide the 2 off from everything first, you're going to introduce fractions from the very beginning. It just becomes a little more confusing. However, if you use opposite PEMDAS each time to guide you while while paying attention to invisible parentheses or parentheses that pop up, it is the path of least resistance. And you know me, I love that path of least resistance. Save yourself some time. Root it in what you already know rather than learning a new trick. So you already know PEMDAS when you're doing the operations as they're given. Opposite operation on both sides of the equal sign, because we want to retain the original value of the equation. And again, we are using these properties again. In this case, we're using the additive inverse. So you get that 3 off. Then you get 2x plus 0 equals negative 3. And 2x plus 0 is 2x. So 2x equals to negative 3. That 2 is attached to that x by multiplication. The opposite of multiplication is division. We're going to divide off that 2. Again, introducing that 1 in front of that x. X times 1 is x. And now we have negative 3 over 2. To me, that's so much easier to do on paper than it is in my head, especially that second one. I could have done the first one in my head, but I'm not going to lie. If I tried to do the second one in my head, I probably would have got the wrong sign, just because I know visualizing things in my head is not the way that I express what I learn, or the way that I learn the best. I learn the best visually. You may be different. Some people are very mentally oriented and can see all of that in their head. A lot of my students, can do mental math and visually see things better than me, because when they were taught their early fundamentals of mathematics, they were taught them differently than I was, and my generation was. And it has been so cool to see that transition. My students looking at these groups of numbers in their head, it's just amazing to me. But I like my stuff visually in front of me so I can check, and recheck again. And there you have it. This is how we solve quadratics using factoring. And this factoring method is greatest common factor. I do have other videos over factoring quadratics using the AC method, and solving with other forms. There's also called the quadratic formula. We have that solving method. I don't believe I have a video over it yet, but my goal is to get one up soon. Now, I do want to say one thing. I am really bad at this myself, so I want to draw attention to it. Let's go back and read the directions. Notice I skipped the second part. Check your solution. And I am purposely doing that today just because this video is 17 minutes long already. And this is somewhat of an easy problem. But I really wanted to dive into that why behind the how, because I see this taught so weird. I see this taught without why do we get it set equal to 0? And the students don't know why we have to get it set equal to 0. They're like, why do we have to factor? If students don't know why we have to factor. Well, this is why. We aren't required to use the zero product property, but we've dealt with these things so much in mathematics. We know that if we can get this in the form of the zero, to where we can use the zero product property, then we can find the solutions. And that goes all the way back to graphing quadratics. So you'll see here I pulled some reference information. To solve quadratic equations by graphing, you'll see that we have our parabola and there's 3 situations. Either we have 2 solutions where it crosses the x-axis twice, and that's where y is 0, okay? And 1 solution where it touches the x-axis. Again, that's where y is 0 and y would only go with 1 x there. And then the no real solution, and that is where on the y equals 0, our graph doesn't cross at all. In other words, y equals 0 does not have a x in the real world that goes with it. Now, when you get to Algebra 2 and Pre-Cal, you will be dealing with imaginary solutions and looking deeper into those. You will also be looking at non-real solutions with the quadratic formula. So for those of you who are out there thinking about, what do I do if I can't factor? Because some quadratics aren't factorable. They'll use that quadratic formula. And sometimes when you use that quadratic formula, you'll find that you have no real solution. You have an imaginary one or a complex number. So I just wanted to bring that back. Notice that I said when y equals 0, we are finding the x's. Look at this problem. It is when, if you're looking at a traditional quadratic in standard form, y equals ax squared plus bx plus c. Y is 0 there in the y slot, and we're solving for the x's. In this case, we have a parabola that goes through y equals 0, or also known as your x-axis, your x-intercepts on the x-axis. We go through the x-axis at x equals 0 and at x equals -3 over 2. All right, so I'm leaving this for you to check via substitution, as that is a part of the directions if you're following this, or if this is your assignment. Well, your math knowledge has just been patched on solving quadratic equations using the greatest common factor, and most notably, the zero product property. That's why we do these things the way that we do them, to use the zero product property. Thank you so much for your time.